We're recording. Here we go. I can't believe it already. So this is a 1.3 example 4. We talked last time about the end behavior when we have a quotient of two functions that are growing for huge values of x or negative x. And whenever the top grows faster than the bottom, and that happens with polynomials when the degree is larger in the top, then it's going to approach some type of infinity or negative infinity as you go out to the end, in which case you would not have a horizontal asymptote. Remember that a horizontal asymptote is not a discontinuity. It is an end behavior asymptote. And there are other end behavior asymptotes. The reason you have a horizontal asymptote, if I can, there we go, B, remember, because they were growing at the same rate, x to the fifth over x to the fifth, the limit was 3/5, and therefore we had a horizontal asymptote at 3/5. It works because if you just divide out the x to the fifths, you're left with y equals 3/5. And what would the graph of y equals 3/5 graph as? A what type of line? A horizontal line. So that horizontal line becomes the end behavior asymptote, and that's why we call it a horizontal asymptote. Well, if we look at this over here, we can actually figure out what the end behavior model would be as well. Of course, the leading terms are really all that matters for huge x. If you were to simplify the leading terms, what would you get? Well, let's just simplify the terms. You get 4 over negative 2, which is negative 2, and then x cubed over x squared would be x. So you could set it equal to y like we would do for the horizontal asymptote, and you have the start of what could be your end behavior model. This is, of course, linear, right? And so your end behavior model would have a slope of negative 2. So if you wanted to draw a line that had a slope of negative 2, it would look something like that. Now, the local behavior of this function, h of x, is going to be all kinds of crazy things. We could have vertical asymptotes, x-intercepts, local max or local mins. But if you were to zoom out on that function, h of x would start looking more and more and more like this line that has a slope of negative 2. And so the function itself would have the exact same end behavior as the line, negative 2x plus whatever the y-intercept is. So if you know that right away, you don't even have to plug in a representative value to see what type of infinity it is like we did last Friday. You could just say, oh, the end behavior model is negative 2x, negative slope. So what would be the limit as we go out to the left? Well, the line goes up to positive infinity, so that would be it. And as we go out to the right, it's going down to negative infinity. So that's what we came up with on Friday. Now, for graphing purposes, it's nice to know where the asymptotes are because they are like gravity. The graph is going to be pulled towards them. A line has one other component that's needed to sketch it, right? Lunch. The y-intercept. And we will find the y-intercept after lunch on example 4. Don't forget your blue out shirts too. I guess they benefit the band. They're $10. And they're blue. All right. We'll pick up with example 4 after lunch.